Yeah, we're live. It is 11:55. Hopefully everybody's doing well. Today I want to talk about some excuse me, geometro math. So we want to talk about I read comments when I did the blower stuff and the nitrous stuff on the Metro engine. And if you go to or belong to some of the Metro groups, there are interesting conversations there, and it's really cool stuff because obviously, if you've got a 1 liter Geo Metro, particularly an XFI like I have, that's not the motor that you want to modify to make lots of power with. But it's all relative, really. I mean, if you can get a percentage power gain like we did with the blower, and when I put like this little thing, if we put a good one on there, my thumb, if we put a good one on there, we'll make even more power, one that's working properly. But if we can get the kind of boost changes that or the kind of power gains relative to the boost, then obviously good things are going to happen, and we can still get good gains. It's just that the number's not very big. So if we have a motor that's making 40 horsepower at the wheels and we get a 50% gain, we've added 20 horsepower. So most guys would be thinking, wow, a 50% gain, that's a lot. And then you're like, yeah, that's 20 horsepower. That's really not very much power. And it's not in a big number, but from a percentage standpoint, it is. But ultimately, the conversation when you post stuff like this, just like with any engine family, is guys will talk about what the things that they need, and you'll get people that say, "Oh yeah, I can make the big number I would guess for this 1 liter Metro engine is I can make 100 horsepower with that motor." Okay, let's talk a little bit about what it might take to make 100 horsepower, but without boost. And so this conversation was about NA stuff. And so some of the things that they've done are put motorcycle carburetors on there, like side draft stuff, kind of like an IR deal on there, which is obviously cool. No matter how it turns out, it's definitely cool. You'd want to do cams and cylinder heads and intake manifold, the normal kinds of things. You could also up the compression and do all the normal things, a long tube header, and all of that stuff is going to help. But if we're looking at, this is the way that I approach stuff. One, if I was looking at this for a Bonneville thing, I would look at records and things like that. But if you're looking at just improving the power output of that combination, or really any combination, the first thing that I look at is, okay, how much power do I want to make? And then the next thing I would look at is, okay, what about the cylinder heads? How much head flow do I need to support the power level that I'm trying to reach? And can that be done? Because if you take a combination where you need a cylinder head to flow 500 CFM, and there's just no way that the head is going to flow that, then you need to look at another option. Because, let's say you want to make 1,000 horsepower, and you have a cylinder head that flows 300 CFM, you're just not going to get there. So you have to have a head that flows way more. And so that's the first thing I would look at when we're talking about this Metro build. So let's say we wanted to make 100 horsepower. And let's say that a stock Metro engine makes, 50 or 60 horsepower. So we want to make 100 horsepower. So the first thing that I would look at, like I said, is head flow. So let's take a look at the head flow. So if we're going to make 100 horsepower from a 1-liter motor, we need to make basically 100 horsepower per liter. And that's not insurmountable. There are factory motors that make that. A B16 Honda from back in the 90s was doing that right from the factory. The thing that it had going for it that most don't have is that it had the VTEC, right from the factory. It had 2 different cam profiles. It also had very, very good 4-valve cylinder head and lots of head flow. It also had good intake manifolds. It also had good cam timing. It also had adequate compression. It also had a really good exhaust system. It also had, windage trays and stuff. And so I think it had a windage tray. I think it did. So it had a lot of things going for it. The Honda guys obviously know how to make power. Unfortunately for the Metro guys, the 1-liter Metro was not designed as a performance application like that B series was, or the K series, or a lot of other motors. So it's not that. So right off the bat, we have a hard time it's an uphill battle basically to get that motor to get 100 horsepower per liter. But let's look at head flow. So what we need to make 100 horsepower from a 3-cylinder motor, and this also makes it harder, and we're going to talk about why, but we need to make 33 horsepower per cylinder. So three cylinders, 33 horsepower per cylinder. Okay, so how much head flow do we need? And the way that I do that is I back calculate it. So if I look at it, okay, if we're making 33 horsepower per cylinder, what would that be on a V8? And so we multiply 33 times 8, we get a 264 horsepower combination. That's really, in the grand scheme of things, that's not a lot of power. So if we look at a 5-liter 302, it makes that much power. And it's got a cylinder head that flows, 160 or so, 160 to 165, 165 CFM. So if we're making on a V8, if we're making 264 horsepower, how much airflow does that require? Well, if we just divide that number by 2, because we know that if we take the head flow on a V8 and multiply it by 2, that will give us a rough estimation on what the power output could be. So if we divide that number by 2, 132 CFM per cylinder will get us this 33 horsepower per cylinder number that we want. So 132 CFM. That would assume, though, that we're making 2 horsepower per CFM, which is not always an easy deal. And when we're trying to do that, all the other things need to also work. So it's not just a matter of having enough head flow. If we have really big cylinder heads, like an LS3 is a perfect example, we have enough cylinder head flow to support, 650 or 700 horsepower. The motor doesn't make that, even though we have the cylinder heads for it. So just having the cylinder head flow is not enough. Having more cylinder head flow than you need is always beneficial. When you're trying to make power, it's a lot easier to not have just the number that you need to make, that equates to, 2 horsepower per CFM. That's not going to get the job done a lot of times. It's a lot easier to have more than you need. The thing is now, the question is, can we get a 1-liter Geo Metro XFI head or Sprint Turbo or whatever is the good head there? Can we get that cylinder head to flow that much? And then if we do get it to flow that much, what lift does it flow that much at? So then do we have a camshaft can utilize where we're getting that big flow number at? So I'll give you an example. Let's say it flows 132 CFM, but flows 132 CFM at 600 lift. That's of no value to us if our camshaft never sees 500 lift, because we're not taking advantage of that airflow. Now, what does the thing flow at 500 lift or whatever lift number we manage to get out of this thing because of the limitations of the camshaft and the rocker and things that may hit each other. If we're trying to go excessive on the lift, we can normally adjust things like, installed height of the valve. And we can clearance things. We could put lash caps on it. We could do lots of different things. We can adjust the spring so it has sufficient spring pressure and coil bind and do that to get the lift that we want. But sometimes there are just interference areas that limit the amount of lift that we can run. So if that's the case, and we can't get the airflow, the CFM we need at that lift, life becomes harder for us. So, but let's say that we can get a 1-liter cylinder head to flow 132 CFM that we need to make this, to support this 100 horsepower, power output that we're trying to make, 33 horsepower or so per cylinder. Let's say that we could do that. So that's our first hurdle. The next hurdle is, okay, if we're going to do that and we're going to make that power, we're certainly not going to do it in the RPM range that the factory motor runs at. Let's say that the factory motor makes peak power 5,500 RPM to be normal for a kind of thing like this. You're not going to make 100 horsepower per liter at 5,500 RPM. If you take a look at a B series Honda, it makes 100 horsepower per liter with its really, really good 4-valve motor that will support way more horsepower than 160 horsepower that they're making out of a B16. But it does it at 7,000, 7,500 or 76 or 7,700. It does that at a very high RPM. So if you're going to make 100 horsepower per liter, you're going to be doing it up in that RPM range. And that's going to require 2 things. first it required three things. One, it required the head flow. The next thing that it's going to require is the cam timing. So if you take a look at the VTEC cam timing on the B16, you see that it has quite a bit of duration, especially for a factory cam, which is what makes VTEC cool, because you can have the mild cam to drive around on, and then you can have the good cam to go even faster and make more power. You've got more lift, you got more duration, you got more RPM potential. That's what makes those motors so cool. You don't have to have, you can have the big camshaft, but you don't have to have the drivability associated with the big camshaft. You can have the drivability associated with the small camshaft, and the drivability and fuel mileage and all that stuff, which makes it great. So we're also on our 1 liter Metro motor. If we wanted to run to 7,000 or beyond, we're going to, and make that sort of power level, we're going to have cam timing that's going to allow us to do that. And then obviously, because we don't have VTEC on the Metro motor, we're going to have to suffer the slings and arrows of drivability to have that bigger camshaft on it. If this is a race Metro build, that's obviously not an issue. We can have 1,000 RPM idle speed and all the things that we need to have lots of camshaft. But figure on, if we can team the cylinder head that has that kind of head flow, figure on a camshaft that's going to be, because of the displacement, the relative displacement of each one of these cylinders, the camshaft gets bigger. So the camshaft that we would run on like your B series Honda motor to make that power output at 1.6 liters with a 4-cylinder would be a bigger camshaft, would be a wilder camshaft, and therefore want to make power at a higher engine speed on a 1 liter motor. Because we know that if we do the calculations on each cylinder displacement, we see that, if we had 4 cylinders on our Metro motor, it would still only be 1.3 liters. So even at 4 cylinders, it would be smaller than that 1.6 B series Honda is. So what would happen is that camshaft would be relatively wilder. That means we could run a little bit smaller camshaft. So, but still figure on something that's going to be high 2 teens to 220 at 50 for a camshaft. That's probably where it would be to make that kind of power level. The next thing is, if you're going to have the head flow and you're going to have the cam timing to allow it to run up where we need to take advantage of it, and the lift, the duration and the lift to be able to make the power up at the RPM range that we're going to want to run it at, and to take advantage of the head flow, we now need an intake manifold. So the intake manifold, kind of like the camshaft, and I would argue even more so than the camshaft, is going to dictate where this motor wants to make power. Now, none of the factory Metro intake manifolds or the Sprint Turbo or any of these factory manifolds, none of these really are designed to make power at 7,000 or 7,500 RPM. So you're going to need a shorter runner manifold. And if you've ported the head, I'd have to look at the flow rate of the manifold also and see if that thing also needs to be ported. If we needed to make a custom short runner intake manifold, if I was doing this project, I'd make an adjustable one. A lot of guys were talking about, and doing a naturally aspirated motor, doing the IR kind of manifolds, doing motorcycle carburetors and kind of a custom intake manifold, and putting 3 of those on there. All of that's very cool. An IR deal probably would make the most power if you were doing this NA, as long as you had big enough throttle valves in there, throttle bodies, or carburetors, but as long as they were big enough to flow what you needed them to flow. And then also with carburetors, if you're introducing fuel, you get the secondary benefit of charge cooling. So if you had side draft carburetors on this thing, which you're introducing fuel, you get fuel cooling, you get more power, and that helps you get closer to your specific output. So then if you got your induction system scienced out, so it had both the flow rate and the runner length designed to make power where that camshaft and the cylinder head need it to make power at the RPM it needs to make this specific output, then you need to look at the smaller things. You would need to look at the exhaust system. Do you want to run a header? Do you want to run a 3-into-1? Do you want to do it merged? I would want to try various different things to try to see which one it responded to once you put these other things on it. Once you decided on your induction system and the cam timing and the cylinder head, and obviously compression, all of those things on an NA combination are certainly going to help. So milling the head, maybe changing the chamber design to a more efficient deal. Obviously, you did a bunch of porting to the head to get it to flow that much. Maybe a bigger valve. Maybe you unshrouded the valve. Maybe you did all of that stuff. But the exhaust system would definitely come into play. It's definitely going to be, this is definitely going to require some kind of long tube header. You'd have to decide what the primary size is. And then, you could try tricky things like you could do stepped headers. You could try different things, different kinds of collector or B pipe lengths. You could try all of that stuff and figure out what was going to work. I think you could probably get there. The biggest hurdle to me would be getting the head flow. If you could get the head flow, now I can't remember what we flow tested a few of the heads, but I can't remember if we could get to this sort of number. It would be nice if that was 150 CFM, and if it was 150 CFM at 500 valve lift, that would make life easy because we know that we could get a 500 lift camshaft in there. That'd be kind of hard to do on a 2-valve motor, I think, with such small ports, unless we did some welding and stuff in it. But if anybody out there knows what these things flow and what they've done on ported ones, until I get back to the flow bench and start testing the things that I have, I won't know that. But those would be all the steps that you'd have to go to figure out how to make 100 horsepower per liter. And like I said, you would start out with something that, that is has the head flow that it needs. And then you go to the next hurdle, and then the next hurdle. And then the nice thing, though, is once you get past the big hurdles, the hurdles actually get smaller after that. Like doing the exhaust system is not really a big deal. Once you get past the heads cam and intake manifold, compression's a fairly easy thing. The header thing is something you're going to have to create because there's not going to be a bunch of aftermarket headers to look for, to choose from for the Metro guys trying to make lots of power, especially trying to make Bonneville level NA kind of power things. Nitrous would make that very easy, and then boost obviously would make it very easy too. But the nice thing is if you could get something that made lots of NA power, then you put boost on it, then our multiplier effect makes life much, much easier. So let's see what you guys got going on. So okay, is it possible to make 100 horsepower per liter with a 100 horsepower per liter with a 1 liter NA Metro motor? Can that motor reach 100 horsepower per liter, do you think? So let's see here. E1337, what's going on? Turbo Sentra, Taylor, Eric, what's going on? Machine shop called oh, Todd, your head's ready to pick up. That's good. Did you get 90 horsepower out of that thing? I've never made 90 horsepower out of a Metro motor, not an NA one. We've done on the Sprint motor, we've done way more than that with the turbo stuff. There's a new AMR 500 blower. Got a bigger outlet on it. Did somebody make a new housing or something? I'm surprised that nobody's ported these actually. I would think that particularly on the inlet side. Mike, what's going on? Shadow Ops, Scott. Good to see you guys. Probably going to try 11-to-1 compression on the Sentra. Maybe I'll get closer to 160 wheel horsepower NA. 138 wheel horsepower is about what I have now, plus or minus 5. Can 3D printer put more lobe on a stock cam? I don't think so. Eric, congratulations on your 15-year anniversary. Flame spray. It's a technique that adds metal to parts in repairs. Plenty of videos on it. I just thought a 3D printer could easily add more lobe. What do you think it's going to print onto the surface of the camshaft? I don't know how the adherence would be. Shadow Ops, you're pulling the 4.8 out tomorrow and putting the 5.7 in. That'll be cool. Let us know when you get that thing running. ITBs on the Metro. Yeah, that's cool. Got my low buck truck 6-liter done. Trying to build the turbo kit now. Cool. I know you have a video on it, but I'm getting a 6-liter built for my 76, 75 set up old square body. Would you go 862 or 243? I have both. Thinking of going 243 and higher compression with pistons. That's fine. I don't know how much power you're trying to make. So if you tell me what the power level is, I think that if I was driving it on the street and I was using pump gas, I would use because you don't have to worry about the extra compression. 62, because you have the turbo. The turbo is going to decide the power. About another S10. This one is a 4-cylinder 5-speed, 260,000 miles. The driver's side frame. Need of major repair. Scott, what motor is in that? Turbo Century Jordan wants to know what generation Century you have an engine. He's got a B15 1.8 that he adores and love to put a turbo on it for nothing more than making cool noise. And the boost, right? There are metal 3D printers. I've seen that, but usually they print something completely out of the metal and that it's only bonding to the other 3D printed material that they're using, not to something else. I haven't seen that happen on 3D printing yet. What Scott, but what engine is it? What 4-cylinder is it? Is it an Iron Duke? What is it? 2.2, no Ecotech. 2002 2.2 liter called the L4. Okay. I was looking up some information on that 2.2 liter. Trying to make 800 wheel horsepower. It's a street build with the 85 intercooler. Also, what compression would you try sticking with? The higher compression makes more power, and it will add boost response and everything. The problem with compression on a street motor is that it narrows your tuning window, and it's not really going to help you make more power. ultimately, because the turbo is going to dictate that. Because you can max out that turbo, you can max out the flow rate of that turbo, whatever size turbo you put on there, and you can do it with 10-1, or you can do it with 11-1. I would go lower compression if it's a street motor. Really, even if it's a race motor, I would be more apt to choose the 10-1, because you're not, unless you're class racing, where this thing is, you're trying to get every last ounce of power out of, every last average ounce of power out of it that you can. If you're not doing that, I would much rather have the safety of the bigger tuning window on the lower compression. Because like I said, you just, to make more power, you just do what let the turbo do what it does and make more boost. I've seen guys weld up lobes on a Briggs & Stratton. Yeah, I've seen guys weld camshafts up and then remachine them. I just haven't seen them do it with a 3D printer. If anyone can make 100 horsepower per liter, you can. I don't know that I can. I don't know until I know what the potential of the cylinder head is. And I have a ported head. I just need to flow test it. A guy in town track races his B15 SER and had it turboed, but last time I saw him, he had a BQ35 swap. It's a lot easier to make more power with bigger motors. So you race the guy, Spank, you race the guy in a Sentra in your Cutlass 3.1 with a 125 shot on it. That's a big shot for that motor. And what's that 3.1 make? Does it make 125? If a motorcycle make 100 horsepower per liter, Richard definitely can. I appreciate the the positivity and the confidence. But a motorcycle does it with a 4-valve head and lots of RPM and a really, really good intake design and wild cam timing that runs at high RPM. It's a lot easier to do that with a 12 or 13 or 15,000 RPM motorcycle engine than it is with a 6,000 to 7,000 RPM 2-valve, much more pedestrian kind of combination. Just trying to get an idea what to do with the 6-liter. Being built ground up, practically stock crank, forged rod, forged piston, maybe 2/3 turbo cam, trying to have something spec'd around. You don't need a custom cam, Nicholas. In fact, either one of the cams that I have will easily do 1,000 horsepower and be responsive. I would say pick something smaller. Don't pick a big stage 2 or a stage 3 turbo cam for that. That's not what you need. It's going to be unresponsive unless you're just wanting something that chops. B16 1.8 liter from a Versa. I had a 1.8 Versa. Can you repeat what head you recommend? I would put 243s on it. I wouldn't have the more compression on that combination. Raptor, what's going on? 3.1 made 160 to 170 horsepower and probably more torque, I think, than the 2.8 Sentra motor, right? But that's got to be a lot heavier, don't you think? All but one of my motorcycles were more than 100 horsepower per liter. Can you machine a Triumph head to mate to your block? No, there are guys that have done the 4-valve Swift head and made it into a 3-cylinder head. I've seen that. But I don't want to do that. That's possible. You could make a 1-liter 4-valve motor or swap a better motor into it. All of that's possible, but I'm just talking about doing it with the existing motor. Up to 225 foot-pounds of torque. That's one thing that the bigger motors do is they obviously make a lot more low-speed torque or excuse me, even average torque production. Yeah, Nicholas, I would suggest if you're doing a 10-1's fine. I'll put the 243 heads on it. I would run the low buck truck cam that I have, or that one step up, the Truck Plus, something like that, the Truck Norris, Chupacabra, any of these camshafts that are smaller, because you'll be much happier with the response rate of the turbo than you would with a stage 2 or certainly a stage 3 turbo cam. They're not going to give you anything. They would give you more horsepower per pound of boost up to the limit of the turbo, which you'll get to anyway. You could get to anyways with either one of the cams. They're just not going to give you the response. At a 5.3 with a Chupacabra cam, same build, forged rod pistons, 76, 75 on E85. Drove it once, felt great, very responsive. Blew up first drive due to rod bolts being loose. The machine shop, yeah, that's not good. Replacing with a 6-liter, but I want a cam with as much, if not more, response. Then don't get a, if you want something that's more responsive than a Chupacabra in the 6-liter, the Chupacabra would be a good cam for the 6-liter. Something like that would be good. It's definitely going to be way more responsive in a 6-liter than a 5.3, because the motor itself is already making a good 50 foot-pounds more torque on a 6.0 than a 5.3. I don't know what intake you're running on it, but the longer the runner of the intake is, the better the turbo response. The smaller the camshaft is, the better the turbo response. And then the smaller the turbo, the better the turbo response. But an S475 or so on a 6-liter with that kind of camshaft in it is going to be pretty responsive. If you throw a set of roller rockers and good valve springs, could you rev it way out to hit your goals? If you're talking about the Sprint or the Metro motor, no, it's not that. That's not the problem. You have to, the valve train would need to be set up to be able to run the RPM, but all the other things would have to want to make power up there. Just putting spring rate in it and revving it after you've gone past the power peak is just RPM. But it's making much less power because the factory intake and the factory camshaft and the factory head all want to make power at that 5,500 RPM range, and you have to change all that stuff to get it to want to make power at higher engine speed. You also have to change the valve train so that it will rev safely out there, but that's a secondary thing. Tim, what's going on? I've run those 3100s in Grand Ams and the 3400s, and we put a turbo on one of them, and it made pretty good power. I've learned whatever cam you want, go one size down. Yeah, and Raptor, that's good advice, and probably more like 2, because everybody wants to go one size up when they're choosing camshafts because they think that more is better. But on a turbo, less camshaft is better. I got off the phone literally 10 minutes ago, told BTR and TSP my goals. They were both recommending stage 2 and 3 cams. I asked them how the torque bottom end was compared to Chupacabra. They said the same. I guess I need to talk to Brian about that. And he needs to talk to his salespeople at BTR, because that's not anywhere near true. You have all of the Dino data that I have up on my channel, and a stage 2 and certainly a stage 3 turbo cam is going to be way softer down low than a Chupacabra or their own Truck Norris or my low buck truck. Any of those, it's going to be way down. In fact, I will tell you how much. It's been a while since I ran a stage 3 turbo cam anyways. So to give you an idea, like a sloppy stage 2 compared to a Truck Norris is down at 3,200 is down 33 foot-pounds of torque. Let's see. And the hot rod cam that they have is the same down low as a sloppy stage 2. It makes more power on top, which is and it's a smaller cam too. It's like a 217 cam, I think. Yeah. So all of those cams are going to be much softer down low. And I don't have obviously I don't have a dog in that fight. I don't care which cam makes more or makes less. It doesn't affect me at all. But this is the reality. I have the test data to back up what I'm saying, and it's 100% accurate. Let's see where I did I know what I can look at. Let's see here. Cathedral port 48. Sloppy stage 2 versus the world. I think we did test the I have a comparison between the BTR stage 2 cam and the sloppy stage 2, and they're almost identical down low. So that cam's not going to give you any more low speed power. And in fact, like I said, compared to the Truck Norris or the low buck truck or Chupacabra, it's definitely going to be a lot softer down low. Everyone puts a 3800 in place of a 31. If you want to go fast, I wonder if there's anything worth messing with tied up in a 3100 or 3400. Well, 3400 would definitely be better than a 3100. And then you could do all the things that you would do to these motors, port the heads. I just don't know what kind of cams and things would be available for those. Let's see. If I had a 351 on a stand, would be logical consider a 393 stroker kit. Just looking for something simple and not having to modify the block or add labor outside balancing. If you don't want to bore it and the bore are straight, then just have the pistons done for whatever bore is there. If you don't want to go to a 393 or 387, I'm assuming that that's going to be bore size, right? But a stroker is a good idea. I made that mistake after becoming a follower of yours. I've learned to be less can be more on the turbo stuff. That's good. But I'm glad that you joined and then you learned an important lesson. Probably needs to make more early model Gen 3 cams. The Gen 3 Hemi cams, is that what you're talking about? Do you port intakes? I don't. I mean, I have, and I would on my own stuff, but I don't. Not something that I do for. And I don't do. I haven't ported any like LS intake manifolds. Pre 3.1s were the best. We were concerned about the transmission when we added the turbo to it. Blake, so you want it run pure oxygen, which is very volatile, and nitrous to ensure that it explodes? I'd really like to see a reputable person flow bench a set of AMC dogleg heads. What are dogleg heads? I'm not familiar with those. I don't think BTR would mislead people like that. Yeah, they're honest people over there. I like all the guys at BTR. My thing is though that in any sales force, if you have a bunch of sales guys, they also might be giving you their personal interpretation of what you should use. And so if they tell the customers, yeah, I should use a stage 2 or stage 3 turbo cam, because most of the people that they talk to are going to think, well, yeah, the only thing better than a stage 2 is going to be a stage 3 because it's bigger. It's one more than that. When the reality is that they probably shouldn't be doing that unless the guy, well, honestly, even if the guy's drag racing, if he's got a S475 turbo, they should be telling them to run the truck Norris cam and not a turbo cam. I don't think that that's a good way to go. I think that if they put if they had a 5.3 and they put a stage 2 turbo camshaft in it and ran the exact same combination with if you had two trucks and one of them had the stage 2 turbo cam and one of them had the truck Norris cam, unless the stage 2 turbo cam had a really big converter in it, if they had the same stockish kind of converter in it, the truck Norris cam would walk away from the other one. I just remembered at work we have an EcoBoost F-150 and a 5-liter. They feel the same. In case anyone's looking at the Fords, we're looking at getting a new vehicle for Lisa. She was looking at the Broncos. Oh, Hemi cams. Yeah, I agree, Dylan. They should do the early ones. I was thinking for the stealth intake. Off topic, but let's use the AC for intercooler on turbo application and see the results. The factory does that. Dodge did that on theirs. Maybe 72 and up. The exhaust part has a little jut out on the side and it's not rectangular or oval. Paid $2,600 for the truck. I probably should have passed it off. Dylan, you're misinterpreting what the reality is. They're not lying. I know that we all want to think that the big bad companies are in cahoots and giving us it's some conspiracy that they're feeding us misinformation, but that's not the case. Like I said, it could be that kid that was answering the phone, that's what his opinion would be, and that's what he would do, and that's what he's telling you. That maybe shouldn't be universal, and so, but he's not doing it maliciously. We're going to leave a little bit early today, so we got 2 more minutes. Let's check our poll. Is it possible to make 100 horsepower per liter with a 1 liter NA Metro motor? 75% are thinking that it is possible. I would reserve judgment until I see head flow. If the head flow is 100 CFM, it's going to be really, really hard to do. Because this is the other thing. This is the other math that I wanted to talk about. So whatever the head flow is on a 3-cylinder, if we had a 6-cylinder of the same displacement, the head would only have to flow 50% of what it flows on the 3-cylinder, because we're dividing the amount of power that we need to make by 2. And so the amount of power that we have to make now per cylinder, if we had a 1 liter 6-cylinder, would be much less. And that's actually why I think that back in the day, Ferrari and Lamborghini, these guys that were making these motors, if you had small displacement V12 motors, they didn't have to flow as much. You have small cylinders, and then if they made, I'd have to go back and look at what their bore and stroke was. But if you had a big enough bore where you could make the head flow pretty well, because these weren't 4-valve motors back in the day. If you had a a big enough bore, and then it was a short stroke motor. That way you could only so that you could get the head flow that you needed. But with 12 cylinders, the head doesn't have to flow very much. It has to flow 25% of what a 3-cylinder flows. So that's not very much. 2-minute warning. Yeah, anything that you could do to get the Eric, I think I will be on tonight. Anything that you could do to get the charge temperature lower is good. The problem is that you're using power, a parasitic drive associated with driving the AC system, which they normally shut off. The OEMs shut off at wide open throttle, but you're having to drive that to make the extra cooling to get the extra power. So it's costing you power to make power. Is there a net, gain from that? You'd have to see. Yeah, Monkey, we went over the RPM. We'd have to, you definitely have to make a lot more engine speed to do it, to make 100 horsepower per liter. And yes, that is what they do on the Demon. So obviously, if they did it at the OEM level, they figured out that certainly for a short burst that it is a net positive gain in power. And then also, if you are able to get the charge temperature lower, even if you balanced out in power the power that it took to drive it and the gain that you get from the lower charge temperature, if you're then able to increase the boost and or timing, then you get more power. So I don't know what their tuning strategy is for that combination when they get the lower temperature, but it's all beneficial. So run E85, run methanol, run the AC intercooling, run ice water, run the scuba tank supercharging, all that. Does the Demon has air to water intercooling, right? It doesn't have an air to air. Yeah, you can add water methanol injection. As long as you can get it evenly to all the cylinders, that can work good. It can certainly help minimize detonation, which is beneficial. And on that note, it is time to go. But I will see you guys all later. There's no balance shaft.